back to my YouTube channel, Massa Tutorials. Please do go to subscribe to this channel so that whenever I post a video, you'll be the first to receive it. Alright, so we are still doing Mat 103 Subsidiary Mathematics, elementary calculus, right? So our subtopic under the elementary calculus is what combination of products, quotients, and what chain rules. Combination of products, quotients, and what chain rule. So now let's remind ourselves on what product rule. When or where we use product rule. Product rule. So let's say if I have a function f of x which is equal to, let's say, u times v. So our function f of x, so uv, that's product. They are multiplying, so I get uv. Now, this function is in terms of what? X, don't forget. Alright, so I want to apply the product rule. So the product rule states that my f prime of x, which means I want to differentiate, right? So I get u, we hold u constant, then we differentiate v with respect to what? X, then plus, we move to the next thing, which is v, then we hold v constant, then we differentiate with u with respect to what? X. So we hold u constant, then we differentiate v with respect to what? X, plus we hold v constant, then we differentiate u with respect to what? X. So we can write it as, let's say, f prime of x must be equal to u, right? Then v prime plus v, then u prime. So this is what we have. This is what we have. So now, let's see for the quotient rule. When and where do we apply quotient rule? So like quotient rule. So let's say we have a function f of x, which is in the form u over v. So this function is in terms of what? X. So we assume that it is u over what? V. Now we want to apply the quotient rule. I always say that you hold what? The denominator, which is v, constant, and you differentiate the numerator, which is u, with respect to what? X. Minus, you hold the numerator constant, then you differentiate v with respect to what? X. Right? Then we divide them by what? V squared. The square of v. So this one we can write it as v u prime minus u v prime all divided by v squared. So this is the quotient rule formula. The quotient rule formula. The quotient rule formula. So now let's see the chain rule. The chain rule, as we discussed previously. The chain rule. Now, if you want to apply the chain rule, you have to take note that if I want to find my dy over my x, which means that I'm differentiating y with respect to what? X, it must be equal to, I differentiate y with respect to what? U, then times I differentiate u with respect to what? X. So this is what we have. This is what we have. So that's the chain rule. We differentiate y with respect to x. So if you differentiate y with respect to x, it must be equal to differentiate y with respect to what? U times differentiate u with respect to what? X. So my y prime must be equal to what? Still, we can get y prime here. Then, so y prime with respect to what? X. Then y prime with respect to what? U times u prime with respect to what? X. So this is what we have. This is what we have. So that's how the formula goes what about. So the y over the x equals what? The y over the u times the u over the x. All right, so now we've done our recall. We've done our recall. So we want to continue to solve examples involving combination of what products, quotient, and what chain rules. So now let's see our first example. All right, so let's see this question. Question one: find y prime if y must be equal to what? X over the square root of what? We have the expression 1 plus x squared. So how can we find our y prime? All right, so let's see. Find y prime if y equals x over square root of 1 plus x squared. So our solution, I have y which must be equal to x over square root of 1 plus x squared. So now let's see. We have to break it down. In calculus, take your time. You see, it's not difficult to take your time and work it out properly. You get it? So here. Alright, so now let's see. Our y must be equal to, I can write this guy as x over 1 plus x squared or exponent half. I can write this square root as exponent root half. Right? Now, I can also say that y must be equal to this guy. I can say that x times 1 over 1 plus x squared or exponent half is true. And again, I can say that y must be equal to x times 1 plus x squared or exponent of negative half, which means I'm taking the inverse of that. So x times 1 plus x squared or exponent of negative half. So which means I can get y equals my x times my 1 plus x squared or exponent negative half. Right. This is what I have. So which is very, very simple and very, very trivial as well. So kindly follow me as we deal with this question. So now, this is not a constant because it's x, right? And we are differentiating what? Y prime, which means we are finding the y over the x. We are differentiating y with respect to what? X, so it's not a constant. And our expression inside the bracket too is not what? A constant, right? So now, how best can we solve this? Because they are multiplying, they are all in terms of x. They are all functions of what? X, right? So because they are functions of x and they are multiplying, so we have to use the product rule. Let's apply the product rule. So our product rule says that what y must be equal to u v. So I say that my y equals, I hold u constant, then I differentiate v with respect to what? X, plus I hold v constant, then I differentiate u with respect to what? X, right? So I have this. So now let's see. My y, my u is what? X. Then my v is 1 plus x squared to the power negative 1 half. So we have this. So now we can differentiate u, which is we differentiate u with respect to x, which is when I differentiate x, I get 1, or we obtain it 1. Now here, let's differentiate v with respect to x. So here we can apply the chain rule. We can apply the chain. You can let u equals 1 plus x squared, then you differentiate u with respect to what? X. Then you substitute it inside so that you get u to the power what? Negative half. Then you differentiate that u with respect to what? X. You get that. When you are done, you come and substitute it into the chain rule formula. Right. But I taught you another way to do that. I said use the general power rule as to let this negative half come down. Right? So it multiplies 1 plus what? X squared. Then we subtract what? We subtract 1. right? Then we differentiate the expression inside. We differentiate the expression inside. We have a constant here, so it goes to what? 0. Then we have x squared here, we get what? 2x. So I get my 2x here. So my differential of a with respect to what? X must be equal to, I have negative half, then 1 plus x squared. Now negative half minus 1. 2 times 1 is 2. Minus 1, negative 1 minus 2, I get negative 3 out of 2 times my 2x. Right. Very, very simple. Take your time and follow. The v over the x must be equal to, now we can see that this guy takes away that. Right. So I have negative 1 times, I can take the inverse, which is what? 1 over 1 plus x squared or x is equal to 3 out of 2 times, don't forget our x. Right. So now, we are still dealing with what? The differential of a with respect to what? X, which must be equal to multiplication of fractions. So we multiply them together. So I have negative x over 1 plus x squared or exponent 3 out of 2. And this one can be written as, I believe you know that 3 over 2 is the same thing as what? 1 over 2 times what? 3, right? So I have negative x over this 1 over 2, I can write it as square root of what? 1 plus x squared or exponent of 3. So this is my differential of a with respect to what? X. I differentiate v with respect to what? X. So now, let's see. We substitute that into our y prime. So we are finding for y prime. So my y prime must be equal to, what is u? You know that our u is what? X. Times differential of u with respect to x, which is negative x all over square root of what? 1 plus x squared or exponent 3. Then plus, what is v? Our v is what? 1 plus x squared or exponent what? Negative half. Times our differential of u with respect to x, which is what? 1. So we have this. Our y prime must be equal to, we can multiply. We get negative x squared all over square root of 1 plus x squared or exponent 3. Right. So now, this one we can write it as plus 1 over square root, because we get 1 over 1 plus x squared or exponent half, which can be written as what? This square root. So 1 plus x squared. Multiplying 1 is the same thing as that. So I can rewrite this as y prime or dy over dx must be equal to, I can bring the positive aspect first, which is 1 over my square root of 1 plus x squared and minus x squared all divided by my square root of 1 plus x squared or exponent 3. So this is the differential of y. Very, very simple and very, very trivial as well. So kindly watch it carefully. Alright, so let's see question 2. It says find y prime if y equals square root of 1 minus x all divided by 1 plus x. So now let's see how best we can write this. You have to relax. You don't have to rush in doing things here. So I get my y, which must be equal to, I have square root of 1 minus x all around 1 plus x. Here. Now, we all know that the square root affects the numerator and also affects the denominator. Right. So I can still write it as y equals square root of 1 minus x all divided by square root of 1 plus x. Can write it as that. Right. So then now, you also know that this square root can be changed to what? Exponent what? Half. Here to the same thing, exponent half. So I can get 1 minus x or exponent what? Half. All divided by 1 plus x or exponent half. So we have this, right? Then we can proceed as if I have it as 1, y equals what? 1 minus x or exponent half. Then this one is over 1, right? I'm separating that. So times I can get it as 1 over 1 plus x or exponent half. So I can get my y equals 1 minus x or exponent half times I can take the inverse of that. So I have 1 plus x or exponent negative half. So now we are multiplying. I get y equals 1 minus x or exponent half and 1 plus x or exponent negative half. So we have this. We've not differentiated what yet, so we kindly watch it. I've just what massaged the question to be what to look so simple for you to what to differentiate, right? So now you've seen this, you can apply what the product rule because you then what they are what multiplying. We have a function here x, here to a function here what x, so we can multiply. So I can use my y equals u times what? V. You all know that our u should be equal to 1 minus x or exponent what? Half. Then our v should be equal to 1 plus x or exponent negative half. So now you can differentiate u with respect to x, which must be equal to, we drop half down, then we multiply by the expression 1 minus x, and we subtract 1 times, we differentiate. The constant is 0. Then if you differentiate negative x, you get with negative 1. Right. So now, let's see. Alright, so let's see. We can differentiate v with respect to x. Let's see, if you differentiate v with respect to x, which must be equal to negative half times down, then 1 plus x, or exponent negative half minus 1, times differentiate things, I get positive 1, right? This one goes to 0, this one is what? 1. So now I have u prime of x must be equal to, I have half times 1 minus x, or exponent negative half times my negative 1. Then we have green prime of x must be equal to negative half, then 1 plus x, or exponent of negative 3 out of 2. Right. Forget about this one. We need to multiply it again. So my u prime of x must be equal to what? We multiply the negative half, then times, you can take the inverse of that, which is 1 over 1 minus x, then we bring our square root, right? So I can get my u prime of x should be equal to negative 1 over 2 square root of 1 minus 1 x. So now let's see for our v prime of x. Our v prime of x, which is the same thing as we differentiate v with respect to what? X, we get negative half times, we take what? The inverse of that. So I get 1 over square root, don't forget, 1 plus x, or exponent what? 3. So I get my v prime of x, which must be equal to negative 1 over 2 root square root of 1 plus x exponent 3. Right. So now we can substitute that into our dy over the x. dy over the x, we can say that the formula is what we hold u constant, then we differentiate v with respect to x, plus we hold v constant, we differentiate u with respect to what? X. So I have my y prime must be equal to, what is our u? Our u is giving us 1 minus x, or exponent half. Then times the derivative of v. Let's see the derivative of v with respect to x, which is what? Negative 1 out of 2 square root of 1 plus x, or exponent 3, plus our v. Let's see v. V, we have it as 1 plus x, or exponent negative half, times our derivative of u, we have it as negative 1 over 2 square root of what? 1 minus x. Right. So I have my y prime equals this half, you can write it as square root. So I can bring negative square root of 1 minus x all over 2 square root of 1 plus x or exponent 3. So we have negative as this side, right? Then plus, you can drop this guy down, you can change it. You can reverse that, right? The inverse. So I get 1 over square root of 1 plus x, right? Then times negative 1 over 2 square root of 1 minus 1. Right. So I have my y prime, which must be equal to, alright, so let's see. So I'll get my negative square root of 1 minus x divided by 2 square root of 1 plus x to the power 3. So we have this. Then I have my minus, because we have negative here. Negative 1 over this 2 comes out. We have, they are multiplying, right? Multiplication of fractions. So we have to multiply it into digits. So we get square root of 1 plus x and times 1 minus x. So we can get it like this. This one is the same thing as difference of what? 2 squares. So we can get to 1 squared minus 10 squared, or 1 minus x squared. So our final answer can be written as, our final answer can be written as, alright, so let's see. Our derivative of y with respect to x must be equal to negative square root, right, of 1 minus x divided by 2 square root of 1 plus x or exponent 3, and minus our 1 over, can write that 2 times our square root of, I can write it as 1 minus x squared. So, well, that's difference of 2 squares. Difference of 2 squares. So I can write that. Right. So this is our derivative of y with respect to what? X. Very, very simple and very, very trivial as well. Let's proceed to our third example. So our next example is we have to differentiate f of x equals x squared multiplying x plus 1 or exponent 3 with respect to what? X. So how best can we differentiate these guys here? So now, our f of x is equal to x squared times x plus 1 or exponent 3. So this one here, what product rule, they've done it very, very easy for you. No massage. So now we can go through it and solve it, right? So now I have it as f of x, our f prime of x, which is u what? V, right? So our f of x is the same thing as u v, right? So our f prime of x must be equal to what? You hold u constant and you differentiate v with respect to what? X plus you hold v constant and you differentiate v with respect to what? X. Our second example, we can also use what? Quotient rule to do that, right? You can also use quotient rule. So don't worry. You can also use quotient rule to do that. So now here we have this. So f prime of x equals u times v over x plus v times du over x. Kindly follow me gradually. So now I'll get my f prime of x, which must be equal to, alright. So let me clean this one. Let's see. So now we have to first locate our u. Our u is x squared, right? Then our v is x plus 1 or exponent 3. So we can find for our u prime with respect to x, which is 2 what? X, right? Then our v is I drop my 3 down, which is x plus 1. Then I subtract 1, so I get 2. Then I differentiate the expression inside the brackets. So when I differentiate x, I get 1. When I differentiate 1, I get 0. So my v prime of x can be written as 3 times x plus 1 or squared. Right. So now I can substitute that into my f prime of x, which must be equal to what is cubed? We have it to be x squared times the derivative of what? V with respect to x, which is what? 3 times my x plus 1 squared plus what is v? Our v is what? X plus 1 or exponent 3 times the derivative of u with respect to x, which is what? 2x. Right. It's very simple. So f prime of x must be equal to, I have this, they are multiplying. You can get 3x squared times x plus 1 or exponent 2, and plus we can get 2x or times what? X plus 1 or exponent of 3. You can get this. So this, we can see that our answer is quite simple here. Or we can see that we can factorize. We can factorize so that it will be very, very simple for us. We can factorize x plus 1 all squared, right? Then we can factorize x cubed out. So I have x out times x plus 1 all squared, multiplying, so I introduce my big brackets, multiplying this 3 x, because the x is 2. So when I bring 1 out, I get that. Then plus x is out, so I have 2. Then this x plus 1 or x plus 3. There are 3, right? But 2 is out, so I'm left with what? Only 1. So I have this. So it can be written as that. Right. Very, very simple and very, very trivial. As well, kindly watch it carefully. It's very, very simple. Let's see example 4. Alright, so let's see. Find y prime if y equals x multiplying x squared plus a or exponent 4. So I have my y, which must be equal to x times x squared plus a or exponent 4. Right. So this one we can use our product rule. Our product rule. So our product rule y is equal to u v. So we can get our u, which must be equal to our x, then our v, which must be equal to our x squared plus a or exponent 4. Right. So now we can find for our u prime with respect to x, which is what? 1. Here too we can say that our v prime with respect to x can be written as you drop 4 down, then we multiply it by the expression x squared plus a, then we subtract 1 from the exponent, so we get 3. Then times the derivative of the inside, which means we are applying chain rule here. Times the derivative of the inside. X squared, we get 2x. This one is a constant because there is no x term here. So it's a constant, so it goes to what? 0. So I have v prime of x, which is equal to, we multiply 4 times 2x, we obtain 8x times x squared plus a or exponent 3. Right. Which is very, very simple and very, very trivial as well. Now, then we can apply our y prime of x, which must be equal to the same thing as we are differentiating y with respect to what? X. So our y prime of x can be written as what? U dividing over what? The x plus v du over what? The x. So I get my differential of y with respect to what? X. So now what is u? My u is what? X. Then times my differential of v. Then I had 8x times what? X squared plus a or exponent 3. Then plus, what is v? Our v is what? X squared plus a or exponent 4 times equal to, we can multiply again this and that. We can multiply. So we get 8x squared, then x squared plus a or exponent 3. Now listen, you cannot multiply 8x squared with the expression inside the bracket. No. Unless you have to open this or expand this, or you have to simplify this before you can use your 8x squared to multiply it. Then plus I get my x squared plus a or exponent 4. So now we have this. But still we can factorize. Y prime of x must be equal to, we can factorize x squared plus a to the power 3 out. So x squared plus a or exponent 3. Then you get 8x squared in, then plus, we get 1 of our x squared plus a. So we have this, which is our derivative of y with respect to what? X. Our derivative of y with respect to x.